I'm Anil Kumar, and in this video we will learn how to solve polynomial inequalities. I will use both algebraic and graphical approach to understand this concept. The question here is, given f of x equals to x minus 2 and g of x equals to 1, solve g of x greater than f of x algebraically and graphically. Well, as you know, f of x equals to x minus 2, it is a polynomial of degree 1. G of x equals to 1 is a polynomial of degree 0, right? So both are polynomials. Now what we are given here is to solve g of x greater than f of x. Let me rewrite. G of x greater than f of x. It really means g of x is 1. So we need 1 to be greater than f of x, which is x minus 2, right? So that is what it means. Now, to solve it algebraically, what we can do is we can isolate x. That can be done by adding 2 on both sides. So let me show you how we do it. We just add 2 on both sides. Now that step you may or may not show. Well, as you do equations, you can bring 2 to the left side. That is what it means, right? So when I add 2 to 1, it becomes 3. So we have 3 is greater than x minus 2 plus 2 is x, right? Minus 2 plus 2 is 0. So we have isolated x on the right side. And we are saying that g of x is greater than f of x when 3 is greater than x, right? 3 is greater than x is same as, or we can say x is less than 3. So that is what the solution is, and this is the algebraic solution. If I have to show my solution on a number line, then I can show this solution like this also. That is inequality on a number line. Let's say this is the number line where we have 0 right there. In that case, 3 is greater than x, or x is less than 3. Let us say this point here is 3. Then on a line we can show like a hole here, not filled in circle, moving towards left. So any value of x which is less than 3 will be part of our solution. So what you note here is that we have infinite solutions, right? So we have infinite solutions. At times we say range of solutions, right? So whenever you solve inequalities, you expect range of solution, right? Now this range of solution I could have also written as from minus infinity to 3. So that is another way of writing the same thing. So what you learned here is that we solved algebraically. We wrote our solution, or let me say the answer, in 3 different forms. First form which we wrote is called inequality. So this one is inequality. And then this form is number line, and that is interval notation, right? You could also write it in set form, including everything in the set, and then write. Let me introduce that also to you, set form. And since it is a very basic video on inequalities, I would like you to understand the whole concept, because set x belongs to real numbers where x is less than 3, right? That is the set form of our solution, right? So what you learned here is algebraic solution, and also how to write answers in different forms. So 1, 2, 3 and 4. Now on number line, at times we will prefer to show this solution on the line itself. In that case, you have to make a circle, open circle, since 3 is not included, but anything less than 3, maybe 2.99 or whatever, is a part of solution. An arrow indicates you're approaching negative infinity, correct? So negative infinity to 3, and of course you can never include negative infinity. So these brackets means that these points are not included. So I hope this part is absolutely clear to you. Now let us look into algebraic solution of the same inequality. So the inequality given to us is g of x greater than f of x, where f of x is x minus 2, g of x is equals to 1, and we'll now show you method 2, which is graphical solution, right? Now in graphical, we just need to graph these. F of x equals to x minus 2. It means it's a linear line. Y-intercept is minus 2, and x-intercept is, if I write this 0, I get x-intercept as 2. So we have 2 points. One is minus 2, the other one is 2. Joining them, we can make a line. That is one way of sketching. Second way is x-intercept minus 2, slope is 1. So rise 1, run 1, rise 1, run 1. Or we could go down and up. Anyway, so what we get here is a line which goes through minus 2 and plus 2, right? Okay, so that is how this line is going to go, right? So it's kind of, I kind of messed it up a bit here. So I should have gone through this point. Since we're looking for graphical solutions, we have to draw fairly accurately, right? So I'm not using a scale, but let me just join these points now. Okay, so that is the line. Okay, so use a ruler, draw a straight line, and well, this rough diagram for me is okay, but use a graph paper and do a neater job. That is what I'll recommend. Okay, anyway, you have understood. We can easily draw f of x. Let me write this as f of x now, which is x minus 2, y-intercept of minus 2, rise and run, slope of 1. So rise, run, rise, run. You get all the points on the line. That is how it is. So first you sketch one of the functions and then the other function. The other function for us is g of x equals to 1. That means this. So let me draw this with a dotted line, g of x equals to 1. So that is g of x. What do we need? We need g of x to be greater than f of x. Now if you compare, this is the point of intersection where both are same. On the left side, this g of x function has a higher value than f of x. Correct? So that becomes part of our solution. G of x is higher than f of x on the left side of 3. Do you see that? Of 3. Correct? So at 3, both are same. Since we are interested in g of x greater than f of x, we notice that the values of the function is higher. So this g of x is kind of higher than f of x when x is less than 3. So graphically, you can easily read the solution. That's the beauty. You can just read it. You don't have to do any calculations. Well, the only drawback here is that at times it may not be accurate, right? So that's the drawback. But anyway, it helps you to understand the concept. You can see g of x has a higher value than f of x if you're considering any point x which is less than 3. That's the whole idea. But with this, I hope you understand both the concepts. We'll now solve polynomials using algebraic and graphical methods, and we'll take up higher degree polynomials in our examples. I'm Anil Kumar. You can subscribe and learn a lot. I hope it makes things simpler for you. Thank you and all the best.